So in our last example, we saw how to complete the square, how to create that factorable perfect square trinomial. And now we're going to learn how to use that to help us solve a quadratic equation. So you guys are learning different methods on solving quadratic equations. You learned how to solve by graphing. Then you learned how to solve with factoring. Then you learned how to solve using square roots. And now you're going to learn how to solve with completing the square. And depending on your quadratic equation, one method of solving would be more appropriate to use than another, which is why we're going to have quite a few options for solving these equations. Okay, enough of that. Let's get down to it. How can you find the solutions of x squared minus 14x plus 16 equals 0? So here's our quadratic equation. If we were to consider factoring first, do we have factors of 16 that add up to a negative 14? We would go through our list and we wouldn't be able to come up with any. So we can manipulate our equation in such a way that it allows us to create a perfect square trinomial that we can then factor, and then we can solve using square roots. So it actually is a way for us to combine our factoring and square roots methods. Okay, so step one, write the equation in the form ax squared plus bx equals d. So essentially, you just want the x squared term and the x term together. This plus 16, we are going to go ahead and get that to the other side of our equation. So we're going to subtract 16 from both sides. And now we have x squared minus 14x equals negative 16. All right, step two, complete the square. We want to complete the square over here with this x squared minus 14x. So what we do is we take our b value, we're going to split it in half, divide it by 2. That gets us negative 7, and then we square that. Negative 7 squared is a positive 49. So what we do with that positive 49 is we're going to add it in right there. But because this is an equation, if I just add in 49 units on the left side of my equation, we're off balance. We are no longer equal because we have to keep this equation balanced. We're going to also add 49 into the other side. That's the only way that we can do this, to have a balanced equation. So when we rewrite that, we have x squared minus 14x plus 49 equals negative 16 plus 49. We have completed the square to create a perfect square trinomial. This right here is factorable. So step 3, write the trinomial as a binomial squared. So what are our factors of 49 that add up to negative 14? If we do this b over 2 and square it, that number will always have factors that add up to your b value. And it will always be the same factor twice. So in this case, factors of 49 that add up to negative 14 are negative 7 and negative 7. So to write it as a binomial squared, we're going to say x minus 7 squared equals, now let's go ahead and add that negative 16 plus 49. That is going to give us a positive 33. All right, now we can solve for x. We no longer have an x squared term and an x term, which means we can just undo all of our operations and solve for x. So I'm going to rewrite this equation, x minus 7 squared equals 33. X is inside this parenthesis, which is locked down by the square. So our first step is going to be to undo that square. Opposite of squaring is to square root. When you square root the x minus 7 squared, the square root and the square cancel each other out, and this x minus 7 just falls out of that, and it does not change. So we have x minus 7 equals. We learned in our last lesson that when we solve using square roots, you get two answers. So we're going to include our two answers right here, a positive and a negative, and then square root of 33. Square root of 33 is some decimal. It's between 5 and 6. I don't know what it is without a calculator, but we're going to leave it as the square root of 33. If we could reduce that, we would, but we can't, so we'll leave it. So now we're going to go back to where x is. We're going to continue solving by adding 7 to both sides. We're just trying to get x by itself. So x equals, now this 7 is not a like term with the square root of 33, so I can't put those together. So here's how we write that. We're going to write the 7 first, and then the plus and minus square root of 33. And there's our solution for x. What that solution means, that is 2 answers. One of the answers is 7 plus root 33. We could type that into our calculator and get an answer that we would like round to the nearest tenth. X also equals 7 minus the square root of 33. So that plus or minus gets applied to that radical, to the root 33. We have a positive root 33 and over here a negative root 33. We can just write it like this though, just a little bit more efficient, but I do want to make sure we understand that that is representing 2 separate answers. All right, now that we have run through it, we can run through this a little bit faster. So here's our standard form of our quadratic equation. We are going to get this term to the other side. So we'll start by adding 9. All I want is the x squared and the bx together. So we just kind of get that out of our way. We have x squared plus 10x equals 9. Now we're going to take our b value, our 10. We're going to divide it by 2. 10 divided by 2 is 5. We square that and we get 25. Now 25 we're going to add in to both sides of our equation. That's what keeps us balanced. So we have x squared plus 10x plus 25 equals 9 plus 25. All right, this is a perfect square trinomial. There are factors of 25 that add up to 10, and it is the same binomial factor. So factors of 25 that add up to 10 are 5 and 5. So we're just going to say x plus 5 squared. And then over here, 9 plus 25 is 34. Now let's solve for x. X is locked down underneath that square, so we're going to square root both sides so that we can get x plus 5 just comes down. When you square root, you get 2 answers, so plus or minus root 34. And then we will, final step, subtract 5 because we are trying to get x alone. Negative 5 is not a like term with square root of 34, so we're going to write that first, negative 5 plus or minus the square root of 34. Now that we know how to reduce radicals, we do want to think if square root of 34 would reduce, and it doesn't, so we'll just leave it as the square root of 34. All right, once we get the hang of it, it's much faster, isn't it? All right, so we're going to just do one more. Let's lock down this square root, or completing the square. X squared minus 8x minus 6 equals 0. Get that c term to the other side, because we just want x squared minus 8x. Now it's going to equal 6. Take your b value. It is a negative 8. We divide it by 2, which is negative 4. We square that. Do you notice every time I square the number, I throw parentheses around that? When you do your squaring, if you're using a calculator, you have to have those parentheses. Otherwise, you'll end up with a negative 16. But when you square a negative number, we know it should be a positive 16. We're going to add in 16 to both sides of our equation. So we have x squared minus 8x plus 16 equals 6 plus 16. We have just created a perfect square trinomial. Factors of 16 that add up to a negative 8. So we're looking for 2 negative factors. This is going to be a negative 4 and negative 4. So x minus 4 squared equals 6 plus 16 is 22. All right, solving for x. It's locked down under that square, so let's undo the square by square rooting both sides. The x minus 4 just falls out of that. And then don't forget, it is a positive and negative root 22. Solving for x, we're going to add 4 to both sides. And we get x equals, the 4 is not a like term with the root 22, so we'll just write 4 plus or minus square root of 22. And then make sure you think about, can square root of 22 be reduced? It cannot, so we will leave our answer like that.